Good evening, everyone. So let us begin with today's video. I think I'm a bit late today in posting this, but anyways, I don't want to miss it. Okay. Well, my name is Atankar Rao. Those who do not know for looking at these videos for the first time. I'm a physics teacher and an enthusiast who teaches physics in an international school. And these videos are about the misconceptions that we observe in students' papers. When we grade the papers, we see that most of the students commit one type of mistake. So as a result of it, I have a hobby of collecting such kinds of mistakes and finding out, okay, what led them to do this mistake. So towards it, okay, so the result is for the past 2 decades, I've been teaching physics, and the result is I've got a collection of problems which people make a mistake. So this is what we are doing. And the current chapter that is now being worked out is on rotation. And this could be applicable for CBSE, ICSE, IGCSE, IBDP, and so on. Okay, now let us begin with the new problem today. The problem here is, it's a pulley-based problem. Okay, most of them would have solved problems on pulleys, but they make a mistake, small mistake here. Let us understand what is the mistake here. So the descending pulley shown in the figure below has a radius 20 centimeter. So this has a radius of 20 centimeter. We are talking about rotation. When we say rotation, definitely pulley will either have a mass or it will have a friction. Okay, two things should be there. If it is kinematics or mechanics, then might be, I will say it's a light pulley. Okay, has a radius 20 centimeter. Radius 20 centimeter. I'll write this in terms of SI units, 0.2 meter. Moment of inertia 0.2 meters, 0.2 kg meter per second square, kg meter square, kg meter square. This is my I, this is my R. Okay. The fixed pulley is light. So this pulley is light. So no mass, no friction. And the friction, the horizontal plane is frictionless. So it is frictionless. Find the acceleration of the block. Since it has some mass over here, this pulley is now trying to come down like this. Okay. Find the acceleration of the block. What is the acceleration of the block? Now the block will now try to move in this direction with an acceleration. Why acceleration? Because this pulley is now pulling this mass over here. Find the acceleration of the block. The mass is 1 kg. So the mass of this is going to be 1 kg. It's already given. Now what does the student do? Student does something like this. First, since the mass of the pulley is known to you and the moment of inertia is also given to you, he uses the formula I is equal to mr square divided by 2, half mr square for this one. So I want to get the mass of this pulley. Let me say it's capital M. Mass of this pulley. Okay, he has used M2 here. M2 here. M2 here. M2 into R square. Yeah, it's not good enough. Okay, so I is equal to M2 into R square divided by 2, which is nothing but the moment of inertia of the pulley above the center. Why center? Because it is rotating around the center, right, with respect to the center of mass. So therefore I should take this. This M2 is equal to, I can now find from this expression, I is known to you, R is known to you. You can easily find out the value of M2. M2 is equal to 2I by R square. Now the value of I is already given. Moment of inertia is given to you. Moment of inertia is 0.2. Radius is also 0.2. Okay, so 2 into 0.2 divided by R square. What is R square? R is 0.2, 0.04. So it should be equal to 10 kg. So the value of mass of the pulley is known to you. Okay, why is this important? Let us see that. Okay, so somewhere we need to know this. Now, usually what we do is we do not start like this. Okay, we start from here. We find out what is the free body diagram for this one. If T1 is a tension, here, then I can write T1 is equal to M into A because there is no other unbalanced force. The free body diagram should be T1 equal to M1 into A. Now, M1, where is M1 here? M1 here, this is my M1. Okay, this is my M1. So M1 is equal to 1 kg. Substituting this, I get T1 equal to A. Okay, this is my first equation. Then T2 plus T1. Let us look at the pulley. Now, there are two forces here. Some students have taken these two forces, two tensions, two different tensions, T1 and T2. Okay, so T1 and T2 are the two pulling forces which the pulley is now having. Otherwise, what will happen? The pulley would have just fallen down directly, right? If there was no pulling force, the string is definitely trying to pulling it up. Okay, so therefore, T1 plus T2 is equal to M2G. Which M2G? M2G is nothing but the mass of this pulley, which we have got is 10 kg. That's why he has taken this. Okay, M2 will substitute 10 into G. T2 is equal to T2. Okay, let me write it down. I missed the first step. T2 is equal to 10G minus T1. Or what I will do is 10G minus What's the value of T1? See, we already got T1. T1 is equal to A. Okay, T1. So that's what he has got it as T2 equal to 10G minus A. Second equation is done. Then, since the pulley is now rotating, okay, I need to arrive at the torque equation. Okay, we have arrived at the free body for this, free body for this. Now torque equation. Torque, what is the torque? See, this is now pulling it like this. Okay, this is the pulley. Now it has been pulling like this. And here, okay, as a result of it, this is also pulling over here. But this pulling is more higher as compared to this T1. As a result of it, now the pulley starts rotating like this, right? So I'll write T2 minus T1 into R. Force into displacement. Why force into displacement? Why T2 minus T1? Because T2 is pulling force, T1 is also pulling force. Now, but you see, this will produce an anti-clockwise torque. But this will produce a clockwise torque. This will produce a clockwise torque. Okay. Since the anti-clockwise torque is larger than the clockwise torque, so I will write T2 minus T1. Okay. These two are in the opposite direction, not larger than opposite direction. And as a result of it, I will write T2 minus T1 into R, force multiplied by displacement. Distance from where I am talking over here about with respect to this point, central point, should be equal to I times alpha. Torque equation. Tau is equal to I alpha. I hope you know this. Tau is equal to I alpha. And then alpha, because it does not slip, so I can write alpha is equal to angular acceleration, which is A by R. And as a result of it, I'll substitute for I, which is 0.2 A, and R. I made a mistake somewhere over here. Yes, I made a mistake over here. This R, what's the value of R? R is 20 centimeter. I should have given this as 0.2 once again. 0.2 once again. Okay, if I make it 0.2, then 0.2 and 0.2 goes away. So you're left out only with R. So T2 minus T1 should be equal to A. I'm sorry, I made a mistake. A. T2 minus T1 should be equal to A divided by 0.2, which should just be equal to 5A. This should be 5A. Okay. So if this is 5A, then what can happen here? Now what I'm going to do is I'm going to add all of them. Which ones am I going to add? See, for example, T2. What is T2? T2 is 10G minus A. This is for T2. I am substituting from here 10G minus A. This is for T2. And A minus T1. T1 is nothing but here. T1 here is equal to, okay, what is that given to 5A? See, from this equation, I'm looking at this equation. Okay, I am substituting for T2 from here, T1 from here, and then I'm going to write this 5A, not 25A, 5A. So as a result of it, 10G is equal to A plus A, 2A here, and if it goes on the other side, becomes 7A. Okay, so in other words, 10G, let me write it down. 10G is equal to 5A plus 2A, which is equal to 7A, or A should be equal to 10G divided by 7. A should be equal to 10G divided by 7. Okay, so he has got an acceleration equation. The value for the acceleration is equal to 10G divided by 7. He's got this answer. But there's a misconception here. Okay, which is incorrect. The answer is incorrect. Now let me explain when can we use this. The method is correct only when, okay, the pulley is not rolling. When the pulley is not rolling, then your torque equation cannot be applied. First thing. Okay. Second thing is that, see, the first conception is pulley is rolling. Pulley is rolling. Okay. And in that case, what can happen is your T2 minus T1 into R. This equation is correct. No use at all. But this acceleration, this is what you need to look at. Okay. So this acceleration, now this is A here, right? This is your A over here. Now, if this is being pulled in this direction of acceleration A, now this string also moves down with an acceleration A. This will also start moving with an acceleration A. Okay. If this goes down by a distance of X over here, this also goes up by a distance X here, while the pulley will move down by a distance of X by 2. Okay. So which means that the acceleration of this would be A by 2. But what is the mistake he has done? He has taken the acceleration to be equal to A. That is where the mistake comes. Okay. So that one has to be very careful. Otherwise, everything is right. Okay. So therefore, this is not going to be A, but this is going to be A by 2. Now, let me solve the correct way of doing it. Let me use it the correct way. Okay. Let us do the correct equation, correct solution. Then, now let us solve this once again. This is my T1. So, I can write T1 is equal to 1 into A, which is A. First equation. Now the same T1 is acting here also. And this is my T2. And now this is now moving, this is moving in that direction by an A, acceleration A. This is also, the string is also moving downwards with an acceleration here. Now, if this string is moving here, see, this string is going like this. So this part of the string is also moving up with an acceleration here. The center of the pulley will start moving down with an acceleration equal to A by 2. Remember, okay? So in such a way, see, how do I know it is A by 2? If you ask me this question, I will give you a simple rule. The simple rule is that I can now say, see, T1 into A, T1 into A, okay? If I take this one, if suppose I have tension here. Now, if you ask me what is the tension experience at this point, tension at this point is nothing but equal to T1 plus T2, right? So that's what we need to take. Okay. So at this point, that means that the total tension here is sum of these two tensions. If the tensions were same, then it will have become T2T. In other words, the tension multiplied by acceleration should be equal to a constant. This is something which you need to know. Okay, a shortcut. Which means T1 into A. Now you have here, if you have two tensions to be equal, then this will be 2T into A1. Okay, should now be equal to the net tension here. I do not know what the tension here. Okay, sorry. 2T into A2. 2T into A2. This is my A2 here. The center of mass of this pulley is now starting to moving in the direction and has an acceleration A2. 2T into A2 should now be equal to T1 into A. T1 into A. Okay, yeah, I wrote like this. So in other words, if tension is same, then this T and this T will get cancelled, and thus A2 is equal to A by 2. That's what we can get. So in a similar way, I can say if the accelerations here are A, then this acceleration would have become A by 2. Okay, maybe if you want to know more, you can write back to me. I can give you some more examples as how to get the acceleration and tension. Okay, now let us continue with this. Otherwise, I'll be wasting my time doing only this one. Okay, so now we have, now what is this now? This is your acceleration. So therefore, let us write T2. Let me write the torque equation. T2 minus T1 into R, force multiplied by displacement, is equal to I alpha, which should now be equal to mr square divided by 2 into A by R, because rolling. Okay, so this goes away, which should now be equal to ma by 2. Is it ma by 2? Once again, you're making a mistake over here. Okay, now what is this A here? A is the acceleration of the pulley. So therefore, this should have been A divided by 2 once again. A divided by 2 over here. So thus the answer should have been ma divided by 4 here. Okay, and mr square, I miss an R here. mar divided by 4. R I should now write T2 minus T1 is equal to ma by 4. Okay, and from the previous exercise, we have come to know that the mass of the pulley is equal to 10 kg. How do I get? I can get this as I is equal to mr square divided by 2. If you just scroll back, we'll get to know how did I do this. And thus I got the value of m to be equal to 10 kg from here. So as a result of this, now I can also write this as 10a by 4, which should now be equal to 2.5 times a. Okay, I get this expression also. I'll write this as equation number 2. Then the last equation, what is it? T1 plus T2, force balances, right? So T1 plus T2, this is the biggest mistake everyone does it. T1 plus T2, upward force is equal to, they just write this as M2 into G, which is incorrect. This would be true only when the upward force is equal to downward force and the object is stationary here. But here object is not stationary, right? The object is moving down. So as a result of this, the net acceleration here should have been G minus A by 2. Okay, so this T1 plus T2 should be equal to M2 value is already known to you, which should be 10 into G minus A by 2, which should have been 10G minus 5A. Is my equation. Now what should I do? I should solve. Now how do I solve? Now from here, T2 minus T1, I can get the value of T2. How do I get the value of T2? Now what I will do is, I will write here, T2 should be equal to T1 plus 2.5 times A. What is T1? T1 is A. So this should now be equal to A plus 2.5 times A, which should be equal to 3.5 times E. 3.5 times E, right? So now what I will do is, T1, what is T1? A. T2, what is T2? 3.5 times A. 3.5 times A. This should be equal to 10G minus 5A, or 4.5 times A is equal to 10G minus 5A. This implies 9.5 times A is equal to 10G, or A should be equal to 10G divided by 9.5. Now, what is the answer I get? This 9.5 and 10 nearly are equal. So if you solve it, if you put G equal to 10 over here, okay, then you might get something like around 10.3 meter per second square. Use a calculator to get this, and that's how you do this. Okay. So what is the misconception here? The misconception here is that whenever a pulley rolls, the acceleration of the center of mass of the pulley would be half of the, what is this? The acceleration of the string. That's the first misconception. And secondly, when you are applying your free body diagram, you should see to it that the net acceleration here is G minus A by 2 and not just G. So if you apply these two, then you will get the correct answer. I hope you understood this video. Do like, share, and subscribe to my channel for more updates. Thank you, friends, for watching this until the end. Thank you. If you still do not understand this, you can write back to me. I would be happy to start with a new video on this. Because this video is a bit extension. I do not know what is your background on pulleys, understanding of pulleys. So therefore, you should know about it in detail. Only then you can understand this. Okay. Just go to your text, use your textbook, H.C. Verma or any other textbook, which discusses about rotation, and then you will be able to understand this. Okay. What do you mean by constraint equation? Okay. The topic comes in constraint equations. You can get to know more about it. Even the Cengage books also gives you decently in a very, very elaborate way. You can go through it also. Thank you.